Hey everyone, hopefully the mic's working. Yep, sounds like it, good. Thanks for joining us this afternoon. I'm here to talk about cloud in general, but more specifically what we're seeing happen in the wild to some degree, and some interesting attack paths and things that we've been exploiting and trying to defend against for a while now. So, first off, I'm sure why this stuff matters probably isn't a surprise to many, but there's a few interesting bits there too. Some common weak spots, things organizations don't think about and where things tend to break down. Common breach scenarios, both what we're seeing in the wild, but also a lot of the more red team style things that we don't think the real world attackers have gotten onto yet. Expect to see that coming through in the next couple of years. Some bits on detection, that's always been my main focus historically, so we'll dig into that too. And lastly, some tips on a few things to take away. Go check out for your own environments and make sure that you've got them down. As to why I'm here and talking, I'm a principal consultant and the cloud security lead at WithSecure, just over there. AWS community builder when I'm not doing that. I do a lot of stuff with AWS. You might also see me at CitySec Mayhem back in 2021 or T2 a few years back as well. Had a good time there, it was great. So I do a fair amount in the cloud. This is mostly going to focus on AWS just because that's what I know, but a lot of what I'm talking about will apply equally to your Azure estates, your GCP. I hope no one here is using IBM or Oracle, but if you are, my condolences. Actually, as a show of hands, who's got some AWS in their environments? Let's see how much. All right, so we've got quite a few people who've poked at that. Azure? Okay, smaller show of hands. Probably for the best, given their record with O days lately. But let's get started. So I don't think it's a surprise to anyone that obviously this cloud stuff's getting pretty big. I pulled some stats and some predictions on where this is going. The market this year, they reckon, is worth $500 billion now. AWS themselves are probably going to generate about $100 billion in revenue. The various parts of the market are changing at different rates, though. I'm mostly going to be focusing in on the cloud infrastructure end of things. There's going to be a little bit of the software as a service stuff, your Microsoft 365 and things, but that's not really where my interests or expertise lie. Obviously, a lot of this data is predictive, but AWS have been hitting about a 30% growth rate for the last 10 years pretty reliably, so it's probably not far off. The problem, though, comes from a security perspective, right? A lot of the old pen testers look at it like this, right? The amount of times I've heard, oh, there is no cloud, it's someone else's computer. It's not wrong, but it does also completely miss the point, and most of the attack paths rely on technologies, tricks, things that didn't exist back in the old DC world. And equally, the other entertaining one when it comes to attack detection, you get organizations rolling out their EDR across their virtual machines in the cloud, and you absolutely should do that. But most cloud attacks are only going to touch on that slightly, or it's going to be a component of the attack path. And if that's all the data you've got, you're going to miss the vast majority of what's going on in your average cloud attack. There's a lot of other data sources, and we'll get into that later on. So when I say a lot of stuff's changed, one of the big ones really is that when you start getting into Kubernetes and serverless functions like Lambda on AWS, there's no direct operating system access. All of the old tricks we used to use for inspecting what was going on, most of that goes away. A lot of the networking changes really quite drastically. You can't ARP spoof in AWS because there is no ARP. So you often also lose visibility from a logging perspective because you can't intercept the traffic and monitor what's going into an S3 bucket. There are alternative options, but you've got to adapt for them. Application security is broadly still the same, but vulnerability classes sort of change in importance a fair bit. Server-side request forgery is the big one for stealing credentials, but there's a few others as well. And from both an offensive and defensive perspective, the way that organizations work with all this technology really affects how we can do security on them, both from an offensive and a defensive perspective, right? If you've got an organization who's set up really well with continuous integration and deployment, it's easy to deploy lots of changes very rapidly. So Netflix say they do hundreds to thousands of deployments a day. Amazon reckon they push every 11.7 seconds into production on average. So this stuff changes constantly. Doing a point-in-time pen test, sort of pointless to a large degree, right? And from a persistence mechanism perspective, how do you persist in a Lambda function that's only going to last for 10 minutes before it dies? You can sit there and repeatedly exploit it every 10 minutes, but that seems a little pointless and very noisy. What we're seeing people do more instead is you look to immediately pivot out of the compute into the control plane layer, the administrative functions of the cloud, rather than stay inside the VMs or inside your Kubernetes clusters. And on that note, a lot of your detection strategies change, as I say. And the big one is a lot of the old monitoring say they support Kubernetes in some way. I'm not going to name vendors, but at least a couple of them, their Kubernetes support is their Linux agent that's completely unaware of Kubernetes or containerization or anything else, and marketing's just rebadged it, right? Equally, incident response. Let's say you've identified a bunch of your data's been stolen, you try and do forensics and work out what actually happened, and the initial breach point turns out to be a virtual machine that was destroyed in a new deployment 2 weeks ago. How do you do any forensics on that? How do you maintain forensic artifacts for long enough that they can be useful should an investigation be necessary, right? The industry's starting to settle on some of these questions. EDR support's getting better, things like that, but there's a lot of work still to do here. Common weak spots. Some of these will be familiar, some of this might be new. Broadly speaking, though, when I work with organizations, a lot of them think about their cloud security inside specific boxes. You've got a workload you're deploying, we've got an application, so someone threat models the little box in which that application lives. And it's one of 150 applications they've got running in AWS, right? Sometimes, if they're thinking about these things in the right way, that might also be including things like their source code management systems, whatever deployment pipelines they've got going on. That's less common than I'd like, but some do. But generally, the bigger picture isn't considered. And even if we're only talking about a single cloud provider, there's probably a bunch of other stuff to think about too. In reality, I don't think I've ever worked with a not startup that was only using one cloud provider. Does anyone here think they've only got one cloud provider in their organization? Well, we got one very brave hand down the front here. I would be surprised, but hopefully for your sake that's true. It's really, really common to see either AWS or Azure as the primary. Google Cloud often hangs around as a secondary one because everyone wants Kubernetes, and their Kubernetes support's better. Then you'll have some poor sod who's got to deal with China, and so there's an Ali Cloud or Huawei or something sitting in the corner that no one really knows what to do with. And then your source code lives in GitHub, you're pulling images down from Docker Hub, all your stuff lives on Slack. Trying to adequately threat model and secure all of this stuff, most organizations don't have the budget, so you have to get better at prioritizing. And the prioritization decisions I often see people make some degree of sense, but probably aren't the best ones they could be making. They often focus very heavily on the internet-facing public presence of the organization and not on all the places where the important stuff actually lives. And to go along with that, I'm sure this mostly won't be news to people, but it's really common to see attackers pivoting around between environments, right? So, particularly common, you start off with a phishing email to steal some credentials or to land some malware as a foothold on an endpoint, and then use that to pivot up and compromise cloud assets. Loads of people use Active Directory to authenticate to the cloud. Most people's Active Directory estates probably aren't as well hardened as they'd like, and so AD admin means cloud admin, off we go from there. Equally, people put stupid stuff in S3 buckets. We did actually find a bunch of SSH private keys in one bucket on an assessment, and we used that to then jump into a bunch of servers in the cloud. And then also, actually, that allowed us to SSH into a box on their perimeter, which then got us back down into their on-premises estate too. So attackers will try and pivot between environments like that. We're not seeing as much of it going from the cloud to on-prem as the other way around, but that I expect to increase over the next few years. So then, common breach scenarios. What are attackers really doing? Good question, and the blunt answer is, I'm not convinced we know. There are various breaches that get reported in the news, but that's reliant on the attackers being noisy enough or the impact being severe enough that it gets reported, and the organization wanting to report it or having to because GDPR or what have you. The providers hate talking about it with a passion. If you go back to about 18 months ago, you wouldn't find a single mention of the word security incident in the AWS documentation or blog posts or anything, because they were banned from using that expression. Thankfully, they've gotten on board with it, and things are changing, attitudes are improving, but it doesn't benefit the providers to publicize security incidents or to help people learn from them, because it risks them scaring less mature organizations that, hackers are breaking into the cloud, it's all bad. Equally, there's a big focus on low-hanging fruit. Organizations look for the lowest common denominator, the easy stuff to spot, And so my expectation is that what we see is biased towards the simpler end of the spectrum, and that a lot of the cool stuff, the interesting attacks, isn't being spotted at present. Speaking of cool stuff though, Cloud 0 days. This has really taken off over the last probably 12 months or so, maybe 18 months. There's a vulnerability database specifically for vulnerabilities in the cloud service providers, AWS, Azure, and the like. They're tracking over 120 that have been found. Of that I'm aware of, one's been exploited in the wild, and no actual breaches or significant impact has been reported off that. You'll see the Israeli firms being the big names in this space. Wiz in particular are the 800-pound gorilla. They've got a team of about 15 really, really good researchers doing very interesting stuff. But Lightspin and Orca have got some great people too. And if this is a space you're interested in, if you want to learn more about breaking cloud providers, Forward CloudSec 2022, the keynote from Wiz there is all about how they go find all these O-days. And given their processes have been producing probably 1 or 2 a month for about the last 12 months, worth a watch. That said, not worth worrying about at present. I expect that to change now that people are looking, but I just wouldn't worry about it really. It's not worth including in the threat model for your average organization. Equally, I'm not going to spend any time talking about this really. We've all seen all the news about all the open S3 buckets over the years. AWS is doing a lot to improve this situation. Things are private by default. There's nice switches to turn on block public access for all buckets in an account. If you're working in AWS, double check that block public bucket setting is turned on, and then forget about this and move on to the interesting stuff, really. Rami McCarthy out in the US did a really interesting talk at B-Side San Francisco where he pulled together all the data he could from AWS-based security incidents over the last 10 years. And I'm going to shamelessly steal a bunch of his data, and in fact his graph here, to talk about this. What we're seeing is, so abuse of stolen, abuse of valid is referring to credentials. The majority of attacks are somehow tied into credentials that have been compromised or abused in some fashion. There's a reasonable amount of application exploitation going on. The other interesting one there is S3 global write access. So this is being used for MageCart style attacks to embed malicious JavaScript into websites to either crypto mine or steal credit card info or these kinds of things. That's happening more than I would expect. You've got to screw things up quite bad before you have global write on an S3 bucket. So yeah, that's a bit of an achievement in some ways. But then in terms of what we've been doing on our engagements, what I'm starting to hear some of the red teams doing this sort of thing, credential abuse, much like real-world attackers, that's the big one. Pivoting in from on-premises, as I talked about. If you're working in an organization that's still very hybrid, there's a lot of legacy Windows and Active Directory and things, the usual play on a red team is do all of the old stuff on premises, steal all the administrative access, and then pivot into the cloud from there. Source code management, GitHub, etc., continuous delivery. That is my personal favorite and what I'll be spending a bunch of time talking about. And then people still build vulnerable applications. Those still get popped. People still exploit infrastructure in much the same way there. So then, for those who are perhaps less familiar with the source code management and continuous delivery attack path, the core of this is you have a setup where you've got some production workloads in the cloud, or maybe on premises even, and we have something storing all the source code and then automatically building and deploying changes out into production as developers make them. Now, the key thing here is, as an attacker, if I have write access to your code repositories, or I can manipulate what's going on in those pipelines, or in fact just steal the credentials straight out of them, then it doesn't matter what you've got in production. It doesn't matter how well hardened that is. Because if I can compromise everything that's deploying to production, then it's usually game over. Those pipelines usually have an incredible level of privilege. And so if I can get in there, that's it. So, example attack paths and some tips and tricks. The tips and tricks are mostly going to focus on AWS, but these broad attack paths apply everywhere pretty equally. And most of what we're talking about here will apply in some fashion, tweaked, to Azure just as well, right? So, as I say, credential theft's the big one. Verizon's data breach reports for the last several years have been guessing at about the sort of 70% mark. So that backs up Rami's data from before. The usual options here, credentials in public repositories. If you're pushing stuff up to GitHub with credentials in, GitHub actually had to introduce a delay on the open source Firehose feed where you see all the public commits. because a lot of crypto mining organizations were monitoring that feed, scanning every single commit that was being made into repositories for things that looked like AWS keys. Then they had their own CI/CD pipelines that took those keys and immediately deployed crypto miners. So the time between those credentials being spotted and an active crypto miner being put in an account, in a lot of cases, was down to under a minute. So GitHub now have a 5-minute delay on that feed. They've also worked with AWS to build a bunch of AWS-specific tooling so that AWS auto-revoke credentials that are found in public GitHub repositories. You get a nice email saying, please don't do that again. But that's only for AWS, right? A lot of other credential types aren't being monitored for like that. If you can break a web app and start sealing the credentials that that's using to talk to all the other cloud assets, that's a great way to get some credentials too. Pretty much everything you run in the cloud as an application is somehow talking to S3 buckets or some managed queue somewhere or a managed database server. And those credential management systems are pretty well built by the cloud providers. But obviously, if the application can get to them and you compromise the application, you've got them too. And lastly, obviously, phishing still happens. It still works. I'll get into some interesting, more cloud-native phishing stuff a little bit later on. All of these attack paths I'm going to talk about, they're composites of things we've done for specific clients. I've very deliberately chopped and changed and moved things around so that we're not, not releasing anything we shouldn't be. But this is all stuff from the real world, right? So some kind of initial credential compromise, let's say access keys in this case from a GitHub repository. But there are a lot of different things that would work here. From there, obviously, we've got some creds. What are they? What do they work with? How do we work out what we can do with them, ideally without getting spotted by the SOC? From that, then, from a reconnaissance perspective, there's a lot of things you can do. A lot of it's quite noisy. By default, a lot of the cloud stuff's quite locked down. So a lot of the old school recon techniques don't really apply much anymore. But there's then a bunch of ways to use those cloud credentials to start running your shells on virtual machines. And at that point, let's say, for the sake of this, our end of our attack path is root on an EC2 instance that's running some kind of database full of sensitive data, etc. So we've got these access keys. First off, which AWS account are we in? Now, my favorite way of doing this is with the STS get access key info command. If you have your own AWS account configured and you pass it the ID of another access key, AWS will tell you what account that belongs to in a way that doesn't record that to the account you're asking about, right? It logs into your CloudTrail, which is the AWS audit logging system, not the target accounts. So there are a number of public lists on the internet as to what account IDs are owned by what organization. It's unlikely you'll find the account ID in there, but at least if you're on a security engagement where you're testing this stuff, you've got an idea if you're still in scope or not, right? It allows us to rule things out. Then, what are the credentials, or who are the credentials for, rather? The classic one with this is AWS STS get caller identity. You can't block this. It's a inherently granted permission, effectively, inside AWS, so this will always work. And what you get back is the user's ID, the account in AWS that it's tied to, and the ARM, the Amazon resource name, for the user. But this might well get you caught. It logs to their CloudTrail. It's pretty noisy, just purely monitoring on this. So a lot of organizations discard all those events by default. But depending on the nature of your environment, it's often possible to whitelist out the noisy ones so that actually you can get a reasonable amount of fidelity off this. And this is the classic, like, hacker or security consultant gets his hands on some keys. What do? We run that. The better option is AWS by default with CloudTrail logs management events. So create, read, destroy, that sort of thing on the resources themselves. It doesn't monitor for data level events where you're reading and writing to and from S3 buckets or queues or things like that. You have to specifically enable those. And as of December last year at least, the publish command for SNS didn't actually log to CloudTrail if it didn't work. So what you can do is you can write to a topic that doesn't exist with the credentials that you've just found. And what AWS gives you back is the ARN from the previous screen of the credentials that you've got, tells you that you're not authorized to perform it. And so that tells you who you are, but in a way that isn't logged anywhere. So that's my preferred go-to for that. It's a nice little trick there. And so now, we've got some credentials, we think they work because it's tied into something. We've not got a message back saying these creds aren't valid anymore. What do we do next? We could start poking around from the perspective of those credentials, but it's usually something I avoid doing. And the main reason for that is anything you do from that point forward, if the blue team's paying attention to their CloudTrail logs, they're going to see it. Any get, list, describe, what S3 buckets have I got, what EC2 instances are running, that all gets logged, and if someone's paying attention, could get you spotted. So to start with, we want to do what we can from an unauthenticated perspective so that it doesn't turn up in their logs. It turns out there are actually some ways to find AWS users and roles in ways that don't log. You can do that without any AWS credentials at all quite often. But in this particular case, the trick is basically when you try and save an AWS policy of some sort on a resource or on an IAM entity, you have that principal field you can see there in the middle. AWS won't let you save it if the principal is invalid. So you can essentially brute force the AWS APIs, brute forcing a bunch of different role names and usernames, and see what comes back as a successful save. Obviously, doing that manually is pretty bloody tedious. So instead, Quiet Riot is something that someone built to do that at scale with a ton of threads against a bunch of different AWS services at once. And equally, Pacu, which is sort of the Metasploit-ish for AWS, has some modules for doing it too. That said, both of these take forever, generally. It's not somewhere I'd usually start, or I'd leave it running in the background while I went poking around in whatever code repositories I've got access to look at the infrastructure as code definitions that have built all this cloud stuff. It'll have loads of role names and things in probably, so you can get an idea of what you might be looking at. The other trick with AWS here is that while it's really hard for us to work out what resources specifically belong to which accounts from the outside, right? You can't do that with S3 buckets unauthenticated. We can work out probably what services are being run in the account, because the role names from the previous step, a lot of AWS services have what's called a service linked role, which is created when you create the first resource in that service. So if you brute force for the list of AWS service linked role names, you can get an idea of what services are deployed in a given account. So that's often how we guess this stuff, right? For Azure, you don't actually have to worry about any of this sneaky stuff because they don't currently log read-only events to their audit logs. It's only things that change stuff, or at least last I looked. So we know they've got the data. At least a couple of my clients have seen them working with it internally, but they don't expose it through their audit logs. Certainly didn't last I looked. So more of a problem in AWS than Azure. But in the case of this particular attack path, one of the service link roles that we're going to discover is for AWS Systems Manager, which is an agent-based thing that runs on your virtual machines in AWS and allows you to do things like automated patching, inventory management, all of these good things. So it's pretty common to see it used. It also provides the wonderfully named AWS Systems Manager Session Manager, don't know what they were drinking when they came up with that one, that allows you to execute commands directly on the box through the agent. This is actually quite common to see these days because it allows you to execute commands through the AWS APIs without having to expose a jump box or anything like that to the outside world. Downside is obviously if you get AWS creds that have got these rights, you've got code exec everywhere. So you can either execute arbitrary commands through it, or there's a start session command and you give it the instance you want to talk to, and you get usually a root shell through that by default, I think. You've got to have certain roles configured on the EC2 instances in order for all of this to work. But if an administrator's gone to the trouble of deploying the agents and is using this service, you've got about a 95% chance that these commands are going to work for you. So that's the first one. Now, looking more at the sort of DevOps tooling end of things, for this one, we're going to say that we fished a developer, and we're in a position to steal the single sign-on cookie that they've got saved in their browser, right? From there, that gives us default developer access to their GitHub repositories. Obviously, developers have got to do their work. They're going to have some access here. We open a malicious pull request from that point, because a lot of the tools used with Terraform in particular, which is a really popular infrastructure as code language for those not familiar, they work in a way that allows us to essentially gain code execution without anything ever being approved or merged in, and we'll get to how that works in a second. So from there, that gets us a bunch of credentials, and in the case of the client engagement, the last time I pulled this off, we ended up with administrative access over their production AWS account sort of almost by accident. I asked them what this AWS account ID was for and got some very nervous responses back. So first up, cloud-native phishing. For a lot of smaller organizations or newer organizations, there's no Active Directory anymore, right? There's no point in running all of that if you don't need to. And these days, sometimes you'll see a 0AD because people want Microsoft 365. It's really common to see people using Okta or Ping or OneLogin or Auth0 or one of these other cloud-native identity management single sign-on platforms. They're usually a single point of access into everything that the organization works with, from their HR systems to GitHub to their emails to everything, right? Interesting supply chain risk there, really. You know, we all saw Okta get breached a while back. Thankfully, it turned out not very much came of it, but I think a lot of people woke up to the idea that if Okta did get breached, their organizations were going to be in for a world of pain. A lot of these have quite interesting security properties too, though. When you first authenticate, they'll enforce multi-factor authentication. They'll have a bunch of risk-based modeling that decides whether or not you're actually allowed to authenticate based on the devices that you're logging in from and the IP ranges you're connecting from and all of these other things, right? But in many cases, once you have that initial authentication and a session token's been issued, you can use that session token from everywhere. We were messing around with this with OneLogin a while back, and once you have that session token, you can spin up a box in DigitalOcean and start doing things against OneLogin with it, and it all just works fine. So once you've got that session token, you've got all the access that that user has to all of the corporate systems, basically. And so from there, we can usually get into your GitHub or GitLab or whatever else it is that you're working with, some kind of authentication into, well, hopefully not Jenkins, but probably Jenkins, or some other CI/CD system. All of this stuff is built with the idea of allowing developers to do their work efficiently and quickly. Less attention than I'd like often gets paid to the security models around all of these tools. And in a lot of cases, once some changes have been approved, they're automatically merged in and deployed straight out into production. And that's all done with a variety of tooling and things that people have built for this. There's a few standard models, and we're going to look at Terraform's usual one here. You'll either see it with Terraform Cloud, or there's an open source tool called Atlantis that operates on pretty much the same principle. Right? So in this case, we are a developer. We've stolen their session token. We got into GitHub. We are now in a position to start looking at their infrastructure as code repositories, and maybe we can't make direct edits to the repository. That's fine. They've been smart enough to require a second set of eyes for all merge requests that are going in or pull requests. But if you're using Terraform Cloud and Atlantis, the model they work on is that they review the merge request, they run Terraform init and Terraform plan to understand what's changed versus what's currently in the cloud. And then they post back to the original GitHub pull request thread saying, here's what's going to change. Helps the developers understand what a given merge request is going to change in their environment. Brilliant idea in theory, makes the developers' lives a lot easier. But when you execute Terraform plan, it executes every single line of Terraform that you've got in order to compare it to what's going on in the cloud. Now, there's 2 or 3 different ways of doing this. You can have a custom Terraform provider, they call it, like you have the AWS provider and the Azure provider. You can write your own and get code exec that way. Or my usual favorite, because it's much easier, there's an external resource type that essentially allows you to supply a bash script that runs as part of the Terraform. So Terraform Cloud will take your merge request. There's been no other interaction required on the developer's part here. We've opened this merge request, and Terraform Cloud goes and executes all of this stuff. And in order for it to go into the cloud and understand what's currently there and be able to do the right diffs, there's usually some credentials in there. And it's very rare that I see people try and differentiate the credentials that are used for Terraform plan versus what's used to actually deploy all the stuff. So these credentials that your script is executing in the context of are almost certainly going to have administrative access over what other AWS or Azure workloads they're working on. So usually you'll find there's some environment variables, or if they're deploying custom runners, it'll be the instance metadata service in AWS or Azure, and you can just pull these credentials they're using straight out. Very, very rarely do I see people properly lock down where those credentials can be used from. It's often a pretty manual process. So you grab those, you put them on your laptop, off we go. This is quite a hard thing to harden against, though. People are still trying to work out how to do it. For this specific thing with Terraform, the best thing to do is basically be scanning Terraform as part of that merge request, to look for the 2 or 3 types of resources or the custom providers that allow you to do that attack path, right? Even just some simple bash scripts grepping for the right stuff is an improvement, and you can set that as part of the merge request workflow to trigger before all of the Terraform stuff, and then basically not proceed any further if you find stuff that looks like it might be nasty. In a broader sense, I don't see a lot of organizations actually doing proper 4 eyes checks on their merge requests. So you definitely want to make sure that whatever's getting merged in requires 2 people to be bad before we accept any of those merges. It's not going to stop all attackers, obviously, but it's a step in the right direction. A lot of people don't treat their pipelines as a core part of their security model. It's seen as a supporting system, as something that we can think about but not necessarily work too hard with, right? We focus on the production workloads instead. That is a big mistake, in my opinion, the more cloud native you get. So threat model for them, pen test them, all the rest of it. Give them a good hard kicking and you'll be surprised at what falls out, I bet. And equally, a lot of organizations, it's seen as a benefit to the developers to allow them to use whatever tooling they want and do whatever kinds of things they want, however they want. The more you can do to reduce down the number of CI/CD systems and the number of tools and things people are using as part of that pipeline, the better a time you'll have as a security team trying to keep all of this secure. Jenkins is a bit of a dumpster fire here, and unfortunately there's not really a huge amount you can do to prevent most of the common issues with Jenkins, like all the old plugins that no one maintains anymore. But for most of the good CI/CD platforms, you can also disable at an administrative level what components of the tool are available to your developers, all of these kinds of things. So well worth looking at that. The less there is there to abuse, the harder a time an attacker's going to have. So that gets us to the end of the attack paths I wanted to talk about. From a detection perspective, the cloud's a bit of an interesting beast. I've been talking about this now since T2 in 2019, but a lot of things are still being worked out, right? There's a few key places where it differs from what we're used to dealing with on premises. One of the big ones is what we've taken to calling uncertainty of malicious intent. There are very few things in the cloud that scream someone's trying to hack you like Mimikatz executing on a box, right? There's not really much of an equivalent for that in the cloud space. In a lot of workloads, you'll find that something that is very obviously bad in most places is perfectly normal. That might even differ between workloads in the same organization, depending on how much freedom developers get. So everything becomes about context. Is this thing normal in the context of this workload? Is this something this developer usually does? We're getting better at that. And obviously everyone's trying to apply as much ML and AI and probably ChatGPT this week too, to trying to work out how to do that better. I still think we're a long way away from that being good. On the plus side, visibility is generally easier to get. You can turn on most data sources and have it automatically apply to 100% of what is in that bit of the cloud. We've moved away from the old problem of, we've got 10 boxes in the corner that our CrowdStrike deployments don't support, and so we've got no EDR coverage there. Or boxes that you weren't aware on your network, because we can just query AWS or Azure and get a complete list of everything we've got. Make sure everything's deployed properly, right? Now, on the flip side, I mentioned earlier on about attackers stealing keys and auto-deploying crypto miners. We've not seen them do much more of that in the automation space yet. But my expectation is, with how easy it is to automate things in the cloud, we're going to start seeing more and more automated smash and grab. So that's easier to do in the cloud world than it was on premises. So I'm expecting to see a lot more of that. We're starting to see targeted attacks against S3 buckets in particular, looking to ransomware the daylights out of them, basically. There's a lot of that going on now, to the point where AWS have finally had to admit it's a problem. So for that, S3 bucket versioning is your best friend for now, because you can then just roll back. But watch this space. I expect we'll see more automated attacks coming in the future. Then, when we think about cloud, we've got a pretty good idea of what sort of log sources apply at the infrastructure as a service end of things. This is your sort of virtual machines, your old school networks, all of that in the cloud, right? We run EDR on our virtual machines. We grab VPC flow logs or NSG flow logs in Azure. That gives us the network visibility. You then have CloudTrail or Audit Log to get a lot of the administrative actions out. Between all of that, you get a pretty good picture. Maybe some of your application logs are useful too. Once we start working up towards the platform as a service workloads, managed databases, Lambda functions, S3, all that sort of thing, we lose a bunch of the visibility that you had with the infrastructure as a service. The further to the top you get on this pyramid, the worse that gets. We still have pretty good visibility. CloudTrail does a lot of stuff, as does Azure audit logs. Amazon lets you do object-level data events, as they call it, so you can see when a KMS encryption key's been used, or who's reading and writing from your S3 buckets if you really want it. Once we get to the top, though, your GitHub, Okta, your CI platforms, these kinds of things, well, yeah, we're still really working out what that looks like. The quality of the logs you get out of those platforms varies enormously. Some of them are really quite good. If you pay enough for GitHub and you can actually ship the logs out of it, they're pretty effective. Okta, likewise, fairly decent. The closer you get to niche SaaS platforms, that often becomes more of a problem in smaller countries running like specific tax or HR systems and that sort of thing. The worse that problem gets. And we tend to find that no one's really worked out what to do with those logs, what to be hunting around for. So every organization who's trying to do effective detection at that end of the spectrum with all of their SaaS platforms, outside of Microsoft 365, they're all working it out for themselves as they go. At the infrastructure end of things, I would say the two big ones to go for are your control plane audit logs, so CloudTrail, audit log, the things that log the administrative actions. If you have only got one cloud log source, go turn that one on now. The providers make it fairly easy to do across your entire organization, so that's priority number one. And then you have the service-specific logs, so if you're doing a lot of like serverless development with Lambda, for instance, it's probably worth looking at the Lambda-specific logs. Likewise, if you've got a lot of stuff that's encrypted with specific KMS keys, that might be a good option too. I got yelled at a few conference talks ago for calling some of the cloud-native detection services essentially antivirus for cloud, but it's not really an inaccurate description at this stage. They're pretty good for catching really obvious bad stuff, right? For instance, don't ever use Kali Linux if you're pen testing an AWS environment. Guard Duty lights up like a Christmas tree, but it's specifically signaturing on the user agent that Kali's using for its requests, right? Really easy thing to bypass. Equally, its port scanning detection is pretty bad in my experience too. A lot of this stuff is improving, and Guard Duty is a hell of a lot better than it was the first time I put this up on screen at T2. I still wouldn't rely on it. It's a lot better than nothing, but if you want an effective detective capability in the cloud, you need your own logs, you need to be doing your own analysis and your own alerting. Then, the closer we get to the SaaS end of the spectrum, the worse the format variations get. All the SaaS providers have their own log formats, totally unstandardized. A lot of the SIEM providers will have ingesters for your Microsoft 365 and Google Workspaces, Salesforce, things like that. But the closer you get to weird niche SaaS platforms, the more you're on your own. In theory, there's this great thing called the Open Cybersecurity Schema Framework that a load of the SIEM vendors and cloud providers are getting behind. But I think they only announced that about 6 months back, so it's going to be a solid 2 or 3 years, I think, probably, before we're in a position where SaaS providers are really standardizing their formats. The other silver lining from a detection point of view, application infrastructures in the cloud tend to be very microservice-based, lots of small pieces, and so any given request from a user is probably going to hit a whole bunch of different points where you have a way to monitor for it in some fashion. So your average attacker's requests and whatever they're doing is going to pass through a bunch of different places where you can pull log sources out and put it in your SIEM. The problem ends up being a problem of cost. If you're running Splunk, for instance, my condolences to your credit card because this will utterly ruin it. But it's worth gathering up a few bits of the key bits, especially. WAF logs, maybe, probably not. But things inside the containers in your Kubernetes clusters like we've got going on here, or like the Kubernetes API server audit logs. There's a number of places where, depending on your specific workloads and how you've built them, you can pull out some quite interesting telemetry there. Right, so lastly, key security controls. What are the big things to put on to try and stop the worst of the attacks in the cloud these days, right? No surprise, number one, multi-factor authentication. Preaching to the crowd, I'm sure, but you'd be amazed at how often I still don't see that in use in all the places it probably should be. The industry's been banging on about principle of least privilege for I don't know how long. I see that in about half the pen test reports that people write. Realistically, no one's ever going to get there. but you can probably get about 80% of the way with 20% of the effort. Work out where the key resources, the key administrative users, those kinds of things are, make sure they're nicely locked down. Try and standardize where you can so your developers aren't trying to write their own IAM policies all the time. There's a reasonable amount you can do there. Equally, reducing or eliminating long-lived credentials. I've got a bit of a personal crusade against AWS IAM users because you generate the API keys once and they live forever until you delete them, and inevitably they get checked into GitHub or uploaded to Pastebin or something bad happens with them. So single sign-on, temporary credentials, AWS's single sign-on workflows give you creds for a maximum of 12 hours at a time. So that's a much safer way of doing things than having these credentials live forever on your hard drive. Provide a back to authentication. So what I mean by this is if you're running a Lambda function, you can assign a role to it, and then AWS handles all the credential rotation and supply to the function for you. The SDKs know how all that works. You don't have to do anything. You just give it the right permissions, and off it goes, right? So don't be hard-coding credentials into things in the cloud where you don't have to. They've deliberately put a lot of engineering effort into making it fairly easy for you to supply the right access to your workloads without having to actually manage the credentials yourself. Obviously, that doesn't apply for things like your workstations and your virtual machines. VDI is often a classic issue here for this. Where you can automate credential management and rotation, a bunch of the privileged access management solutions and things like that will provide means for doing some of this. That said, there's a reason it's at the bottom of the list. It's generally a lot of effort and comparatively low value in the grand scheme of things. So I'd get to that once you've done all the rest. Avoiding people in production. This one usually pisses the devs off pretty bad. They don't want to be told that they can't have access to production anymore. So what you have to do is get to the point where they don't need access, right? Robust logging for an operational level for everything that's going on in their production accounts. Having a CI/CD system that allows them to push changes so fast that if there's an incident, they can just follow the proper workflows instead of having to go poke around manually. That said, most places are never going to get there, so you need some kind of production access control mechanism. I've seen quite a few organizations now building things that provide a jump box on a per use case basis with a single use user, and the requests for those are then logged and audited, and the security people can pay attention to that. If you get to that stage and you've still got some budget left this year, then the logs from your production access control system feed all of those straight into your SIEM so that your security teams can monitor what the devs are doing once they do get into production, right? Most of your devs aren't going to be doing anything bad, but if something should happen or if a dev gets compromised or what have you, being able to see exactly what they did in production because you've got the bash logs from what they did in the jump box is really, really useful. Blast radius is a bit of a pithy term, but what I mean by this is break out your cloud infrastructure. Please, for the love of God, don't just shove everything in the same AWS account. I still see people doing that occasionally, but thankfully it's happening less. Have separate AWS accounts or Google Cloud projects, or I can't remember what Azure calls them, for each of your workloads, ideally. Even if you can't get that far, even just having dev and prod in separate things is a pretty good starting point. That applies at the network level too. I still see a lot of people joining things at the network level with their VPCs, VPC peering. Even saw one case where a client was VPC peering with a network owned by a third-party provider who they had no visibility into whatever, and they just opened the gates right up at the network level. The other common problem point here is what I'm calling shared services. So it's common to see a single Jenkins box that deploys everything across an organization's entire estate, or having a single secrets management box somewhere that everything connects back to. If that's not handled properly, then that's a key pivot point that attackers will use to bounce around. Where you can, use separate pipelines and all of that sort of thing. At least one for dev and one for prod, ideally per environment. And to the surprise of absolutely no one, I'm sure, secrets management is still one of the big problems in the cloud. So it's well worth paying very close attention to where are the application teams storing the secrets their application used? Are they hard coding those in? Are they fetching them from somewhere sensible? The providers give you a lot of good options on that front. You've got Secrets Manager, you've got Key Vault for Azure. There's a few good options there. checking in on how they're shared and rotated. It's no good having them up there and in theory secure, but the devs have still got them on their laptop and they don't ever get rotated. And lastly, how do you know when secrets are leaked, right? One of the really valuable things I've seen a few organizations do now is just have a security guy run Trufflehog or one of these other secret scanners over all of their repositories on like a quarterly basis, just to make sure nothing's been checked in that they've not spotted. You'd be amazed at how much stuff that turns up, especially in larger organizations. And that at least then means you know that you've got to rotate all this stuff, right? Better to know than not. And lastly, with the amount of cloud stuff that's going on in most organizations, this idea that you had a central security team that did security and that was that has to go. We don't have enough people who know what they're doing. There's a general lack of knowledge and skills on a lot of this stuff still in the security world. And so those people who do know about it tend to cost quite a lot. So if you want a career trajectory, this is quite a profitable one right now. And there's usually too wide a spread of technologies, multiple cloud providers, a whole different stack of DevOps tooling. Kubernetes is its own beast that I don't even want to touch, really. You have to push all this down into the engineering teams, right? We've been trying to get them threat modeling and shifting left and DevSecOps and all the rest of it for a while now. But at the concrete end of things, having them do some of their own threat modeling helps them get better at security anyway. So definitely try and help them out with that. Leaning on them to build a lot of your security automation for the cloud is a really good idea. They're generally better devs than the people in security teams for a start. And the carrot you can use is, we're going to build all this security tooling anyway. It's in your interest to help us build it so that it works in a way that you actually can live with and that you don't hate yourself for, right? It's also a really, really good place to hire people from or poach into your own teams to help with the cloud security stuff. I've found it much, much easier generally to hire a ex-cloud engineer and teach them to do cloud security than to take someone who's been doing like old school networks and mainframe stuff for 20 years and get them thinking in the cloud. So well worth thinking about that if you're struggling to hire for these sorts of security roles. And obviously, the sooner you fix security issues, the cheaper it is, and the more you can automate, the more you can do. So all the stuff everyone's been saying for ages about putting stuff in your pipelines to scan for bad things in your source code, all of that still applies. Checkov, worth checking out for infrastructure as code. Really powerful, open source. Just take it and put it in your Jenkins pipelines, and it'll find a lot of the more common cloud security problems for you. So, to wrap things up, well, cloud's a bit of a different ballgame. The broad security principles that we've all used for years all still applies. The way that it works and the way that organizations are building and maintaining this stuff means that the practical applications of a lot of the security stuff we used to do change quite significantly in many cases, right? In theory, if you know what you're doing, I would argue the cloud's probably easier to defend and monitor than a lot of our old school on-premises stuff. In theory, it's built for it. In practice, most organizations are struggling to get a handle on how much of it they've got and where it is and who knows about it and having enough people who understand it well enough. So I don't think we're going to get to that for most organizations for a while yet, but I think we're moving in the right direction. Key security controls to take away. No surprise, as I say, MFA all of the things is the first thing you ought to check for. Segregating and hardening your individual environments so that it's hard for an attacker to jump from one to another is really valuable, given that the cloud is by default obviously out on the internet. And put a particular focus in on your code management platforms, your CI/CD pipelines, these sorts of things. Treat them as the crown jewels that they really are actually for your cloud security. And with that, I think we've got time for some questions, potentially. And we've got a microphone there if we've got any questions. Or have I just stunned the whole room into silence? Corey, it can't have been that good. There we go, we've got one down the front here. Sorry, there's a microphone just coming.
Okay, you talked that the development and production pipeline should be separated, but in a sense, shouldn't there be one concrete quality assurance pipeline that goes through the development and the quality assurance and the production? So how would you separate them from each other?
Right, so the question is, how do you separate dev and production when really you should have a single pipeline for the lot? I would run both off the same source code repositories, It's just that you want to make sure that whatever's doing the deployment, that particular step there, is separated for your dev accounts from your production, so that if an attacker gets into one, they don't also have the other. And so the way that I've seen organizations do this so far is, as I say, you run it all off the same repository, and then once it's been promoted out of the development stages and all of that pipeline's run fine, it's then merged into a branch that is approved to go run through production. So all the steps that happen in the dev pipeline are all assured before it gets merged into the branch that then runs down the second one. Hopefully that makes sense. Good. Any other questions? All right, in which case, I'll be around for a while down here, and if not, you'll probably see me elsewhere in the conference the rest of the day. Thank you for joining me today. I hope you've enjoyed it, and I'll see you all over a beer.